Imagine you're building a messaging app where you store the contact information of your friends, and a food delivery app where customers can easily add, remove, or rearrange items in their order right up until they check out. Both the lists are dynamic in nature. Earlier, you learned the fundamentals of array lists, including their dynamic resizing capabilities and ease of use. Now let's explore how they work in real-world scenarios to truly appreciate their power. Let us consider developing two distinct apps, a messaging app and a food delivery app. Both apps handle lists that change frequently. Whether you're managing a contact list in a messaging app or a customer order list in a food delivery app, the data is dynamic and can increase or decrease. As a result, a structure that effortlessly adjusts to the increase or decrease of customers is needed. Array lists shine in these situations, making data management easier for developers. Let's start with the messaging app. Users regularly update their contact lists by adding new friends, removing old contacts, or rearranging entries. A data structure is needed to accommodate these changes smoothly. ArrayLists manages these updates efficiently, maintaining a flexible and adaptable contact list. Let us suppose you have a class named Friend, with properties phone number and name, with the required accessor and mutator methods, and an overloaded constructor and a toString method. As users make new friends, they must add them to their contact list. Using an array list, create a list called contact list to keep track of some contacts. You will use the generic system of declaring array lists. You learned about these in the reading Declaring Array Lists. If you are not sure what that is, please go back and read it first. Here, you start off by creating an array list named friend list capable of containing friend objects. The list is empty at first. When you initially use the add method to add your friend Tony, the array list gets bigger to fit the first contact. Similarly, when you add Alex and Taylor, the array list grows to accommodate the new friend objects. In other words, the list grows dynamically as new contacts are added. There is no need to worry about how much space you initially allocated. The array list takes care of that for you. Now let's say you want to remove someone from the list, like Tony. Since each friend is an object of the class friend, there are two ways that you can do this. You can remove by index or you can remove by value. We can observe that the friend list adjusts automatically, shifting elements and preserving its organization without any disruptions. We can do the same thing by passing an object of the friend class. But you must note that the object passed must be the object that was initially added. For example, creating a new object and trying to delete would not work because there would be different objects and so they would not be the same. In order for the comparison to work, you would have to override the toHash and equals method of the friend class. To do this, go to the friend class and right-click on an empty area within the class and select Generate. Then select Equals and Hash Code. In the modal dialog, select Template to be Java 7 and Higher. The Get Class Comparison expression is selected and the Use Getters when available checkbox is selected. Click Next. Now in the next screen, ensure the checkbox next to both the properties are selected. Click Next. Ensure the same for the next screen and click Create. This generates the methods to compare using the values of the name and phone number of the class. Now run the main class. It works. For the sake of simplicity, let us assume that we are dealing only with an array list of strings. Imagine you're looking for a contact named Tony on the list. Now the ArrayList class provides you with a method named indexOf to search for a value. The method takes a value and returns the index of the position at which the value occurs in the array list if it is found. If it is not found, it returns -1, which would signify that it is not found, since the index value cannot be -1 as it starts from 0. You use this method to get the index of the value Tony. Since it may not exist, you use an if statement to check if the value is not -1 and only then try to access it. If you do not put the if statement, then it will throw an index out of bounds exception for the index -1. Then the get method uses that position to retrieve the actual contact name and stores it in the context variable and displays it. The same can be applied to the friend object. Remember, this will work only because you had overridden the equals and hashcode methods to compare by the properties. Let's now focus on the food delivery app example. In a food delivery app, orders can be added, removed, or adjusted before finalization. ArrayLists manage these frequent updates with ease, providing the flexibility necessary for dynamic order management. Customers often modify their orders, adding or removing items until checkout. ArrayLists adjust dynamically, expanding or contracting as needed. This capability is vital in scenarios where order sizes fluctuate significantly. For example, if the customer wants to add more items after removing the salad. When you add Caesar salad to your order list, using orderlist.add and in brackets Caesar salad, what's happening behind the scenes is pretty cool. The order list automatically adjusts its size to make room for the new items. You don't have to worry about whether there's enough space, the list just expands as needed. When you use the add method with a defined index, you're telling the order list to place tiramisu right at the top of the list at position 0. If tiramisu is already somewhere else in the list and you want to move it to the top, simply remove it first using the remove method by passing the object name, like tiramisu, and then place it back at the first position. This process of reordering is super efficient with ArrayLists because they automatically shift everything around for you, keeping the list organized without you having to manually shuffle elements. It's a quick and easy way to rearrange items exactly how you want them. ArrayLists are equipped to manage both small and large orders with equal efficiency. Whether the list contains a few items or dozens, ArrayLists effectively handle the variability, ensuring optimal performance and memory management. In scenarios requiring real-time updates, such as replacing garlic bread with cheesy breadsticks, ArrayLists enable these changes to be made effortlessly, keeping the order list accurate and up-to-date. With this code, you first check where garlic bread is in the list using the index of method. If the index isn't -1, meaning garlic bread is found, you can instantly swap it out with something else, like cheesy breadsticks, using the set method by passing the index value and object cheesy breadsticks. This allows you to make real-time updates to the order, ensuring everything stays accurate and up-to-date without any delay. It's a quick way to keep the list current and relevant. In the fast-paced app development world, where data constantly changes and user expectations are high, choosing the right tools can make all the difference. ArrayLists stand out as a versatile and essential solution for managing dynamic data. This video explored the practical application of ArrayLists in real-world scenarios, showcasing their ability to enhance any app's functionality and user experience. Remember, using the power of ArrayLists not only simplifies development, but also ensures that your applications can adapt to whatever challenges come their way.